ただいま留守にしております。ファックスをご利用の方は送信してください。電話の方はピーという音に続けてお名前とご用件をお話しください。
SUMIDA famous clinic, very nice.
Sajio, is one of your first scientific publications in the field of cryopreservation as well as modern cryomedicine?
Yes, this one.
This one.
From the George Chime publisher. Yes.
Transfusion of blood preserved by freezing. Enormously.
いや、それ意味は、ほら、今日学会やったでしょ。外国のお客さんみんな連れてきてね、クリニックで今ガチャガチャ言って見てるんだよ。
Old story, it's 1973, really. There is very old story. And there is human life, and there is a professor, Sumida's life.
Yes, at that time I'm very much proud. I could publish this book from the Leaping Court, 1973.
73, congratulations.
And now we have a good possibility to look at the whole SUMIDA's scientific library.
All publication is the 21st century. I discarded 20th century's book.
In the past century.
Yeah, all of them 21st century.
I will send you some samples.
Yeah, thank you. Yes,
So,
yes. Send this one to Isoda.
To Isoda, yes, please. So please show me your last publication, your last books or papers, original, or your fish. Your fish.
Yes. This is horseshoe crab.
Horseshoe crab.
Horseshoe crab.
Oh.
So staying on the earth.
On the earth,
5
yeah.
billion years ago. Yes, this blood
Extremely,
is very important.
Yes.
DNA has such a tendency or character to hold their shape.
Very interesting.
5 billion years long.
It's very interesting, and the long, extremely long
Yes.
time.
You can see
What is it?
When you come to the United States, Washington, D.C.,
Yeah.
it's the Smithsonian Institute. I took this picture.
Oh.
Horseshoe crab. Yeah.
Oh, very interesting fact.
Yes.
There is scientific event.
Cambodian age.
Cambodian age, and which year was? Please
5
repeat.
billion years ago.
5
Cambodian.
Cambodian. 5
explained here.
billion years ago. So very interesting investigation, very interesting research, really. Please explain and...
5% culture incubator.
Yes.
5%, including the horseshoe crab.
It's your private personal bank.
Yes, no, yes, and to continue the study.
To continue the study on
bone marrow culture, stem cell culture, which are preserved for 40 years long. Very important publication by Father Basil Lugier. Biodynamica.
A biodynamica.
Full set of only one in our country.
Yeah, and which year is are these books? All books published.
First one published 1934.
1934. 40 years ago. 41 years ago.
Yes, 1934. This one contributed by Arthur Rowe.
Arthur Rowe.
Yes, Arthur Rowe, he bind whole publication.
Yes, and
contributed to my clinic. Another one is the world very famous edition.
Yes, what
Life
is?
and Death at low temperature.
Oh, Life and Death at Low Temperature.
Perhaps you know.
1940.
1940. Published by Dr. Homason. He published continuously European Society of Cryosurgery.
Yes, yes.
Yes.
Homason and later Maiwand has...
Maiwand published another one.
Another one, yes.
Video Broadcasting Corporation asked me to come to visit foreign country.
Yes.
I visited the Ukraine.
Oh, so interesting.
Low Temperature Biology Institute in Kharkov.
Who is this man? No.
This one is a mathematician in United States. He liked to waiting to be frozen by the cryonics company.
Oh, interesting.
He is believing his frozen dead body will be resuscitated.
The whole human body. Could you please be so kind? Could you show us the microscope? How old is your microscope?
This one I bought 40 years ago.
40 years ago.
But still alive. Very effective.
Yes.
We can take a picture. This one.
And after 40 years you can take pictures without problem.
Yeah.
And you can connect a camera.
Yeah, this one camera.
And you could take...
This one new.
The camera is new and you
this
can take...
40 years old. But the camera is new. No problem.
And you haven't problem to connect camera to your microscope and take pictures. It's not problem.
No problem.
Today, Professor SUMIDA has presented 3 original presentations in several and different scientific fields of cryomedicine. And one part of this presentation was performed and was done here in this scientific work space and on this place. So the human life is mosaic, consists of old and new particles, and the SUMIDA's scientific life consists of this combined mosaic, old and new research.
Blood cells, stem cells, colonies.
Oh, please.
Stem cells, which are cryopreserved 40 years ago.
Oh,
yes.
Very interesting.
Yes, very hard to encounter colony of monocyte.
Colony of monocyte.
Monocyte.
Which you cryopreserve 40 years ago.
Yes, of course. This one is not monocyte, erythroid cells.
Oh.
Colony. Beautiful colonies of yes.
Yes, very nice picture, and quality is very high to look at, to observe, and to describe this.
High magnification like this. Yes.
Yes.
So beautiful.
Very beautiful, and
yes.
And now you take these stem cells into liquid nitrogen or not?
Of course, liquid nitrogen.
Yes, please. So, please return back.
Back to original place.
There is original place.
So, we have to close.
For next 40 years.
Now, next observation in 4 days.
In 4 days you will observe.
Every 4 or 5 days we observe, and the colony formed. We change the medium, new.
Yes. Very nice. Thank you very much. Thank you very much. Research place, and there is research space by Professor Sajio SUMIDA today on Thursday, November 22nd, 2012 in the late evening.
It's a time to start the plenary lecture, and this lecture is a basic and primitive lectures, and consisted with a history of cryosurgery and modern techniques of cryosurgery, and we can study the exact history of cryosurgery. Professor Sajio SUMIDA, he told about the history of cryosurgery. Just to start.
Thank you very much, Dr. Harada, to introduce me. I like briefly introduce you the history, mainly of history of International Society of Cryosurgery. These slides, which are showing today, are used for the first time at the plenary session of 11th World Congress of International ISC in Lisbon in 2001. And since then, the slides have been demonstrated in the Congress of every 2 to 3 years until 2010. On the occasion, those slides, as the reorganized form, were shown in the first course of cryosurgery, sponsored by the our Japanese Society of Low Temperature Medicine in Tokyo, November 11 to 12, 2000. Because nothing can advance without knowing the history. History, therefore, sometimes so important. ISC history is also important to make us progress. This slide shows the number one, first description of cooling human body appeared in hieroglyphic description 3500 BC. But this cooling is not cryosurgery, just cooled the human body to treat pain and inflammation. Pointer is
the bottle here. It's the green one.
Okay. This means that cool the diseased portion, not freeze, just cool, so little like this. The chronology of cryosurgery in Europe and Far East, cool application was performed in Egypt, as I showed in slide. But actual freezing to treat cancer, the first time in the world, which was performed by James Arnold. Okay, moment. Oh. Pointer is this.
The green. Where's the green?
Pointer?
Pointer.
Thank you. James Arnold, 1845. Arnold used the combination of water plus salt and ice. The temperature decreased to -24.4. This is the eutectic point. And this bug is applied to the tumor, for example, cancer and itself, on the surface of the body. Of course, it was impossible to apply inside the body. The therapeutic use of gas gave impetus to the cryosurgery. 1861, so James Prescott, Joule, and William Thomson, they too discovered the so-called Joule-Thomson effect. So after that, we could use the liquid air, liquid gas, liquid nitrogen, and so on. Cryogenics, terminal word of cryogenic, this came into use by James Dewar. Dewar's kettle is very popular now to use the preserve the temperature, hot water, not only hot water but cold water. After that, the cryo application using liquid gas used to treat or cryo destruction of the human disease on the skin, mostly skin. And like this, cryo treatment to apply using liquid air, CO2, or nitrogen, and others are used to treat the human disease on the surface of skin. This gentleman, this is Professor Dohi. He was the first person who used he used carbon dioxide to treat skin disease. He wrote down this report in the journal of urology and dermatology. It was you can see here, 1911. he described such a short paper, and I translated like this. But it's very interesting. He suggested, it's described in the short report, dilation of the lymphatic vessels, round cell infiltration was observed in the field of frozen area. That means the immune response occurred in the field of the frozen tissue. He used the rabbit ear drum. So I'm interested in cryobiology in 1964, and first presentation was in the 1965 at the annual meeting of the Society for Cryobiology. Here we can find Irving Cooper here. This is banquet. I'm sitting here like this. At that time, cryocycle instrument that is gas versus liquid nitrogen, liquid cryogen was discussed every time in such a meeting, mostly in the cryobiology meeting. So we used 3 types of cooling method. First, change of phase. Change of phase, we use the liquid gas. And evaporation, when evaporated, heat removed from the diseased upright place. And second one, adiabatic expansion. We are using adiabatic expansion, Joule-Thomson effect. And third, thermoelectric refrigerator, Peltier effect. Unfortunately, Peltier effect is not so developed at this moment now. So we are recently we are using some Joule-Thomson effect to cool and to cryo-destroy the disease portion of the tissue, like this. This is the ice ball, of course, you know. Apply into the anal cancer, for example, my experience many years ago, using like large size of cryoprobe, the 7 millimeter external diameter. But the cooling power is very strong, very strong. Sometimes we use this large size of application of the cryoprobe. Adiabatic expansion, Joule-Thomson effect accomplished the renaissance of cryosurgery at the end of 20th century. And 21st century, mostly we are using the Joule-Thomson effect using cryoprobes and others. Of course, in dermatology area department, physicians are still using cotton soap and also cooled metal to treat the skin disease, because that one is very, very convenient. This is the cryodestruction, cryoablation of the cancer. So, and at that time, it was 1972, so first Congress of cryosurgery. Dr. Hoki talked briefly today at the morning session, opening ceremony. Next. Dr. Hoki was looks very young, but he, perhaps you can understand here. Today he came here with a white wig. A person from And today, so most cryosurgeons worrying about these things. Because unclear ice front, frozen, unfrozen margin. Second, freezing of irregularity from the target. Ambient preservation of refrigerant, and for control of minimum temperature, length of frozen time, optimal freezing temperature. What temperature is the best to destroy the disease tissue? 5 is solving method, how to take the time to slow freezing or quick freezing, which is better. That is the solving method. These 5 points is very important today, still now. Cooper did mostly the very important thing, and because he introduced the cryoprobe we are now using to treat the many kind of diseases. But sometimes he was criticized by other doctors who objected to surgical techniques that were not tried on animal first. Animal experiment first, but Cooper did not try animal. So he answered, if I had operated on 10 patients, they all died, I would have been wrong. He objected. I had the ultimate responsibility to be right. I am treating desperate patients who have come to me for help, not at experiment. So he is a man of very strong will. Unfortunately, he terminated relatively early, 60 a little. And I'd like to shortly introduce our ISC Society's chronology. First Congress held 1972 Vienna, of course, and next Turin, and third, the Valencia. This one was actually the first Congress, but discussion who participated these Congress, so they decided to call 1972 Congress will be the first, and second Turin, and third the Valencia. I participated since the Valencia Congress till now. San Remo, Manila, Athens, Beijing. I served the president at 1986. And again, I'm very much honored to be nominated the 16th president. This slide shows the number of papers presented at the Congress. Totally, next one, yes. Totally about 1,124 papers presented. For past 15 times of World Congress. Mostly the dermatology. Oh, sorry, I cannot use smooth. Dermatology occupies the #1 cases treated by freezing. 171. And second one, proctology area, second. And third, general surgery, and fourth, the thoracobronchoscopic use to treat the lung disease, and so on. No. So I'd like to introduce some person who contributed to the development of our society. He is Dr. Giovanni Secchia, Hashek, and Lubarist, who came from Greece, urologist, and Gonçalves, Portuguese, and Gonda and Arlene, and so Reuter. Gonda came from the United States, and he taught the cryoimmunology and cryosurgical development to Richard Ablin. And Reuter, he developed endoscopic freezing actively. Therefore, he would be the father of the endoscopic cryosurgery. No. Cryoimmunology appeared so recently, but this will be very difficult and perhaps very important, interesting findings will be coming from the research of the cryoimmunology. Because when we freeze the cancer and frozen tissue, we destroy frozen tissues, will be captured by the phagocyte of the dendritic cells and others. The dendritic cells present the cancer antigen to the lymphocyte lymphocyte 4 and 8. That means humoral response and cellular response, two-type response will occur after cryosurgery against the very active antigen of tumor. Therefore, cryoimmunology is very important recently. So, I like to introduce much more histologically. Unfortunately, in this limited time, I just introduced the beginning of the cryosurgery and the cryoimmunology. Thank you very much for your attention.
Thank you, Professor SUMIDA. Thank you.
Dear Sajio, it's been a continuous pleasure and a great honor to know you and to enjoy the many meetings we had all along the past 30-something years. Being invited in Japan in 1978 at the occasion of your Congress, I was witnessing the broad spectrum of your research, the sharpness of your vision for cryosurgery and cryobiology all together, as well as your leadership. Since that time, you have pursued with success in your cryogenic laboratory the dream of combining the findings of basic science with a clear and strong determination for improved clinical application. I can't forget, and I am indebted to you for the high recommendation you made to the US government in 1998 when I came from France to this country to pursue my researches in direction paralleling your work. I can't forget either the beauty of your experimental investigation on the rat's mesenteric vasculature change under cryogenic application. It's been a trigger and push for developing new concepts on combinatorial molecular therapy and cryogenic surgery. You are an example of integrity and commitment to your goals, and your spirit is that of youth. At 80, you still look like a 45 young and brilliant person. Please go ahead with the task of your life and keep the dream alive. Have a great birthday, my friend, with all your family and friends. I'll be with you in thought and art. Very best regard, Sajio.
I like to start my lecture. This is the original title. Original title is The Variability and Differentiation of Bone Marrow Hematopoietic Stem Cells, Mesenchyma stromal cells and umbilical cord cells, cryopreserved minus 196 degrees centigrade liquid nitrogen temperature since 1972.
Dear Honorary President of the ISC, Professor Dr. Sajio SUMIDA, dear Sajio, dear friend, happy birthday, happy 18th Jubilee. We are thrilled to express you our cordial congratulations on your anniversary year. We are highly estimated your excellent contribution to the historical development of the ISC and modern cryomedicine. Glory in the special festivity in your scientific and human life. Best wishes, Board of Governors of the ISC.